Hey everyone, and welcome back to the channel Learn Basics. Today, we're diving headfirst into the fascinating world of robotics. From factory floors to our very homes, robots are changing the way we live and work. So, buckle up, because we're about to explore everything you need to know about these amazing machines. Robotics, a multidisciplinary field, encompasses the design, construction, operation, and application of robots. These machines, ranging from simple automated devices to complex artificial intelligence systems, are transforming industries and everyday life. Here's a comprehensive look. Fundamentals of robotics. Definition: a robot is an automated machine capable of performing tasks with varying degrees of autonomy. They often possess sensors, actuators, and a control system to interact with their environment. 2. Components. Sensors. These gather information about the robot's surroundings, including cameras, LiDAR, sonar, and tactile sensors. Actuators. These are the robot's muscles, enabling movement and manipulation. Examples include motors, hydraulic cylinders, and pneumatic systems. Control system. This is the robot's brain, processing sensor data and directing actuator movements. It often involves microcontrollers, computers, and sophisticated algorithms. Power source. Provides the energy to operate the robot, batteries, or external power. Types of robots. Industrial robots used in manufacturing for tasks like welding, assembly, and material handling. Service robots. Designed for tasks in non-manufacturing environments such as cleaning, delivery, and healthcare. Mobile robots. Capable of moving around their environment, including wheeled, legged, and aerial robots. Drones. Humanoid robots. Designed to resemble humans in appearance and movement. Medical robots. Used in surgery, rehabilitation, and patient care. Key technologies and concepts. Artificial intelligence, AI. AI enables robots to learn, adapt, and make decisions. Machine learning and deep learning algorithms are crucial for tasks like image recognition, navigation, and natural language processing. Computer vision allows robots to see and interpret images and videos, enabling object recognition, obstacle avoidance, and navigation. Navigation and localization. Robots need to understand their position and navigate their environment. Techniques like GPS, SLAM, simultaneous localization and mapping, and sensor fusion are used. Manipulation and grasping enables robots to interact with objects, involving precise control of robotic arms and grippers. Human-robot interaction. HRI focuses on designing robots that can safely and effectively interact with humans, including voice control, gesture recognition, and collaborative robotics. Robotics Operating System, ROS, a flexible framework for writing robot software, providing tools and libraries for various robotics tasks. Applications of robotics. Manufacturing, automation of assembly lines, welding, painting, and material handling. Healthcare, surgical robots, rehabilitation robots, and robots for patient care and drug delivery. Logistics, automated guided vehicles, AGVs, warehouse robots, and delivery drones. Agriculture, automated harvesting, planting, and crop monitoring. Exploration, robots for space exploration, deep sea exploration, and hazardous environments. Construction, robots for bricklaying, welding, and other construction tasks. Service industry, robots for cleaning, hospitality, and customer service. Military and defense, drones, unmanned ground vehicles, and robots for surveillance and combat. Consumer robotics, robotic vacuum cleaners, lawn mowers, and educational robots. Challenges and future trends. Ethical considerations. addressing issues like job displacement, robot autonomy, and safety, advanced AI and machine learning. Developing more sophisticated AI algorithms for improved robot perception, decision-making, and adaptation. Improved sensor technology. Developing more accurate and robust sensors for better environmental awareness. Enhanced dexterity and manipulation. Developing robotic hands and grippers capable of handling a wider range of objects. Collaborative robotics. Cobots. Designing robots that can safely and effectively work alongside humans. Swarm robotics. Developing systems with large numbers of simple robots that can coordinate to perform complex tasks. Soft robotics. Designing robots with flexible and deformable materials, allowing for more adaptable and gentle interactions. Increased autonomy. Developing robots that can operate independently for extended periods in complex environments. Robotics and the Internet of Things. IoT. Integrating robots with IoT devices for seamless data exchange and automation. Robotics and cloud computing. Offloading computing-intensive tasks to the cloud to make robots smaller and more efficient. Robotics is a rapidly evolving field with the potential to transform numerous aspects of our lives. As technology advances, robots are becoming more intelligent, adaptable, and capable of performing increasingly complex tasks.